Okay, guys, in this platform, we want to consider typical questions again on our transformers. I want us to get rid of this part and understand the difference that we are going to have on a three-phase. Remember, we talked of the transformers on a single phase, working with the single phase, whereby you are just working with the normal consideration as you are used to. So working with the three-phase connection of the transformers, it is actually a combination of the three single-phase transformers which are connected. So this is the condition that you're given here, whereby we know that the three single-phase transformers are connected together to form a three-phase transformer. So this is the idea that we are having. So the question was to show by means of a neat, fully labeled circuit diagram how these single-phase transformers are connected to form what is formed at the end, a delta star transformer, which is to act as a delta star unit, as a single unit. They are connected together to form a single unit. How is it connected? That is the question. All right, so this is the diagram that you're supposed to consider where we are given this connected to give a single unit at the end. So you can also consider, in this case, what we are worried is the part of the input, what we are having. Remember your delta and also your star. That part is not gonna change. So the marks that you're given is for 3 for the common for the connections on the primary side plus 1 for the bridge piece on the secondary. So meaning to say all the connections that you're given are supposed to be properly presented, and also the bridge that you have on the secondary side. So make sure that all the connections that you are given, they are properly presented. All right, so they are properly presented. So that is the major part that you're supposed to consider in each and every situation. So it's only, guys, I had another diagram that I wanted to explain, which is similar also to just this one. I'm just gonna gonna work on that separately so that you understand the other part. But anyways, I just hope you saw the diagram that you're supposed to have. All right, on 8.2, that is the major important part now on our calculations, because there we are given a 90 kVA three-phase delta star connected transformer is supplied at a 2.2 kilovolt if the secondary phase voltage is, okay, so there it is a three-phase. So considering that it's a three-phase, there are different connections. It can be a delta to a delta. There are different connections. We can have a consideration of a delta connected to a delta. We can have a star to a star. We can have a delta connected to a star. We can have a star to a delta. There are different connections that you might be given. So when answering this question, understand how the connections are. Understand how the connections are. So this tells you what is on the input side, which is the primary side. This tells you what is on the output, which is the secondary side. So we have got the secondary side, the primary side of the transformer. So in this case, what are we given? That is what you're supposed to consider. We are given that this is delta star connected. So if it is a delta star connected, it means what we are having on the input, it is a delta. So we are going to have this, that's 8.2. Just gonna have a sketch. I'm just gonna have a sketch so that you will understand when I'm to explain later on. Remember, we say this is a delta star, so we are going to have a delta in the primary. Okay, so we're gonna have our connections. Remember your connections for the delta. We're gonna have something of this nature. These two can just meet here. All right, so this is the input, which is in delta. Okay, so we are given our input in delta, and the output is being given as what? So if you have to consider at the output side, so you're just going to have our coils here, then we consider our output, which is a star connection. So there you are considering a star connection. So let us just have, let me just put it a closer, on a little bit on top. So just gonna have a sketch, but guys, it's not actually necessary for you to have this as long you understand what is it that you are working with, as long you understand what is it that you are working with from each connection that you are given. So this is it, guys. We are given the star at the end, which is our output, the secondary side, delta to star. So this is what we have. The transformer is supplied at, which is the input that you are given. It is supplied at. So this is the primary side, but as the supply, which is, remember, there's a three-phase. So this is the supply that we are given, which is the line voltage of what? Of the primary side. So you're going to have V1L, which is the line voltage of the primary side. So this is 2,2 kilovolts. If the secondary phase, the phase, but of the secondary, so on the secondary side, we are given the phase voltage, which is 240 volts. But on the primary side, we were given the line. It is supplied from the supply, that is the line voltage. So that is what you're given. And remember, it's a 90 kVA, meaning to say we are given the voltage rating there, our kVA, that is 90 kVA, which is the rating that you are given. So this is it. That is our information. So consider properly how you're given that. 8.21, calculate the turns ratio of the transformer. So we need the turns ratio. Knowing that when working with the turns ratio from the formulas that I explained from the single phase transformer that we're talking about, we're dealing with a single phase. The turns ratio is not going to change from what we had. The turns ratio, which is N1 over N2, that is our turns ratio. It is equivalent if we have got these turns, it's fine. But we do not have that. So what is it that we consider on a three-phase? We consider now the voltage that we are given, which is the phase voltage. So we're going to have the phase voltage of the primary to the phase voltage of the secondary. It must be the phase. This voltage must be the phase voltage. So you consider the phase voltage of the primary, the phase voltage of the secondary. So in this case, if you have to consider we do not have this, any of this we do not have. But what about this part of the voltages that you're considering? The phase, the V1, we do not have. This is the line voltage for the primary side. So we do not have this. V2, we are given it as the phase voltage. We have this, but we do not have V1. So now you have to calculate V1 according to the connection that you are given. It's a delta. So let's go back to our delta connection. What is it that we understand in a delta? The relationship between the line voltage to the phase, because what we need is the phase voltage, not the line. What is it? In a delta, it's an advantage because the line voltage is equal to the phase voltage. So it means the phase voltage of the primary is the same as the 2,2 kilovolt. If it was a star, we are going to consider something else. This is a delta. The voltages are the same. So in that case, we are going to consider the voltage that you're given as it is. So meaning to say we have this voltage 2,2 kilovolts, that's 2,2 times 10 to the exponent of 3 over the voltage that we have for the secondary side, which is the phase voltage of the secondary side, that is 240. So this is going to give us the turns ratio, which is N1 as to N2. So in this case, if you are to divide, that was going to be 9,167. So that means our turns ratio in this case can be considered as 9,167 as to what? As to 1. So remember the turns ratio as to whatever that you're given as to 1. Okay, so if it is 2, 2 to 1, 3, 3 to 1, like that. So that's our turns ratio. From the phase voltages, that is the most important part. All right. Let us consider 8.22, which is the primary line current. Okay, from the primary side, so we are considering this is our primary side. And on the primary side, it's a delta that we are working with. What is it that we can consider or that we can use in common? Remember our KVA, the rating. Remember the rating. The rating is calculated as the apparent power. And this apparent power can be used as an advantage in this case, because remember that the apparent power, which is given as the rating of the transformer. This is the one that you're considering there, given as the rating. But remember, guys, this is three-phase. So in a three-phase, it means this is going to be the square root of 3. Considering the voltage, we are going to consider the line voltage to the line current. But what are we considering from the primary side? So this will be 1, this will be 1 from the primary side. So that is what you're having there. Considering this is the primary side. Remember the rating. On a single phase, you're not having this. It was a single phase. Now it's a three-phase, guys. Square root of 3. Remember your apparent power. So the question is, we need, in this case, remember, this is just to calculate the primary line current. This is what we need, the primary line current. So we can calculate it. Just make it the subject, because we've got everything in this case. We have got everything. So in this case, divide by the square root of 3 pi, then this side also, you divide. That means you are having the primary line current is the apparent power, which is the rating of the transformer that you are given. That is 90 times 10 to the exponent of 3. Everything over what? The square root of 3 times the voltage that we have, which is the line voltage of the what? Primary side. What is the voltage there? That's 2,2 kilovolts. 2,2 kilovolts. So that's it. So there we are going to obtain the current, which is the line current on the primary side. So you must be careful with what you are working with. Okay, so this was going to be 23,619 amps. So that is how you can determine this line current from the primary side. You consider what you're given. We have the rating. Remember, the same rating that we are talking about, this same rating that we are talking about as can be given also as the square root of 3 times on the secondary side. It will be the same thing. on the secondary side. It will be the same thing. But because we need the primary, so we use it for the primary. Because we need it for the primary. So the same formula can be used on the secondary side. All right, 8.23. The current delivered to the load while the transformer is connected at full load. When it is now connected with the current delivered to the load is at the output on the secondary side. The current that is being taken to the load. What are we considering? You're considering a star. You're considering a star. This is the output that you're given. So what is going to be the current? So the question is, can we use the same kVA? Yes, we can. Remember that in a star, considering the currents, the line current is equal to the phase current. So by calculating the line current, I'm also calculating the phase current, which is the current that is to be delivered at the load. Remember what I said about the kVA. It can be used in both conditions, the primary, secondary. Okay, so I want us to get back to that. 8.23. So we are going to consider, because that is the easier part that we have there, the kVA that we are given. So as we saw from the last formula that we had, we ended up having the current, but this time we are considering the current on the what? On the secondary side. So it is going to be that reactive power. I mean, the apparent power that you're given, which is the rating of the transformer, divided to what? We had the square root of 3. This time, instead of having V1, we are going to consider V2 of what? Of the secondary side, which is the line voltage. Are we having the line voltage this side? This is a star connection where we are given the secondary voltage as the phase, not the line. So that's where our star connection is playing a role in a star. What is the relationship in terms of the voltages? In a star, remember that the line voltage is equal to square root of 3 Vp. So these two, they are not equal like what we had before in a delta. It was a delta when we took this. It was the delta connection. Those two are the same. In a star, the relationship, remember, does not change. So it means in order for us to obtain the line voltage, which is the one that we need in this case, we are going to use our formula. So that is the line voltage on the secondary side is going to be the square root of 3 times the phase voltage that we have on the secondary side, which is 240 volts. So that is going to give us 415,692 volts. So that's obtaining the secondary voltage, which is the line voltage. And by having this, we can substitute into our formula that is the rating of the transformer, 90 kVA, that is 90 times 10 to the exponent of 3, the square root of 3 times the voltage, which we got as 415,692. Remember the square root of 3 there, I discussed about this. We are in a 3-phase. So that is going to give us the current, which is 125 amps. And this is exactly the same as the phase current. Remember, we are working with a star. And in a star connection, the currents are the same. Current that we have on the line is the same as the current that we are having on the phase. So you see that most of the calculations, they are related back to what you understand on the power, the power that you're considering, the rating, which is the apparent power that you're working with, the kVA. But considering under a three-phase, everything must be considered. The connections that you are given, how are they given? How are they given? Is it a delta to a delta? Is it a star to a star? Is it a star to a delta to a star? Whatever that you are given, the first part is your primary side. The other part is your secondary side. So the way that you are given here tells us this is the primary, this is the secondary side of that transformer that you're given. So that's how we answer these typical questions. So we shall see typical questions of this nature so that we just refer to our questions. How are they given so that you do understand how these questions are given at the final and like in your typical exams, how are you going to expect these questions to be asked as? So you consider this and also that part of the single phase, revise also that part of the single phase. That can help. So they can ask you a single phase, they can ask you a question on a three phase. So just revise both, okay?